So now let's get into the main part of the presentation, which is the tiered storage. To simplify the tiered storage, basically what it means is you can have this different type of drives in the same chassis. So you can have SATA drives, SAS drives, or SSD drives. They're all in the same chassis, which they all can operate at the same time, and they all have different speeds and different pricing. The only thing that we require in our chassis is, which I think it's a reasonable thing to ask, is all the drives in the of the same type, they all should be in the same rate set. So all the SATA drives should be in the rate set 1, SAS rate set 2, and a rate set 3. And these rate sets, they all show up in our GUI as individual resources. So when a user is creating a volume, he can see that, okay, I have a 16 SATA drive, and this is my capacity, so I'm going to put this volume that I'm creating on a SATA. Or if he requires a higher performance, he puts it on SSD. Obviously, SSD drives are higher price, but it gives you a higher performance. So that's where the tier storage comes into play, that you can decide where to put your volumes depending on your application, depending on I/O performance and all of that, where you put your volumes and where you put your applications on. So the difference again between these drive types there are two things. One is performance, and another one is the cost per gigabyte. And obviously, SATA is lower than SAS, and SAS is lower than SSD as far as the price-wise, and the performance-wise is the other way around. SSD is better than SAS, and SAS is better than SATA. And so these are the things that affect the performance: the type of drives, speed of the drives, drive interface, which is the 3 gig or a 6 gig. There are a lot of SAS drives that have came up with a 6 gig interface, and some SATA drives are providing 6 gig, and SSDs are moving towards 6 gig. Most of them are 3 gig right now. But I think they will all eventually migrate to a 6 gig SATA or SAS interface. And another thing that affects the performance is the I/O size, and the 4K, 64K. So the I/O size and that is dictated by the application. For example, SQL, for example, it might use the 4K I/Os, and another application might use the 64K. So depending on the I/O size, the performance will change, and also the RPM of the drives, which affects the performance, number of drives in a rate set, and the rate level. All of these affect performance. So we did some performance tests, and I wanted to show you some results that you can get some idea about how these different factors affect the performance. Our performance was basically, a performance test was being done with one of our IPSAN appliances, which was a Voyager. We had a 10 gig switch, we had one Windows 2008 server, and one 10 gig interface coming from that server. So just remember, the Vega had only one 10 gig, so the maximum you could get out of this was about, the physical speed would be 1,000 megabytes per second. That would be the max physical speed. The drive types that we had a SAS drive, 146 gig 15K, and also the SSDs were 64 gig Intel drives. And we had 2 rate sets in the backside, and with 8 drive each, and one single port 10 gig coming from the server. So let's look at some charts. This is the random read. If you look at the random reads, and IOPS. This is actually IOPS. Just look at the difference between the these top two. If you look at the chart on the right-hand side, it shows what they are. And they are RAID 0 and RAID 5 on the SSD drives. So just look at the difference between the IOPS of the SSD drives versus these two, which are SAS, and these two are SATA. So it is drastically different, the IOPS for a random read. For a random write, it is also drastically different. If you look at the top one, is the RAID 0 SSD. But in the right, if you look at the second best is actually RAID 0 SAS. So that's why I said the rate levels also affect the performance. So, I mean, you've got to consider several factors when you're deciding on the type of storage that you get. But obviously, SSDs generally are higher speed. If you compare them to, I mean, overall performance in a typical environment, which is the mix of a read and write, SSD will be higher than everything else. In a random read megabyte per second, if you look at it, it's actually these top two are again the SSD, and if you look at this again, we can achieve much higher speed with the SSD drives than the SAS or SATA. And since we only had 1 10 gig coming from the server, if you can see, we top off around 900 megabytes a second. So the maximum physical limit of a 10 gig is about 1,000 megabytes, but because of some overhead of everything that on its way, we could achieve up to 900 and something megabytes a second, which is pretty good.